Hey guys, here Math Muscle back with another video, this time on triangle inequality. For example, why is the triangle inequality even necessary? Well, this could be necessary in many different places, but what it is, and maybe you're asking what it is to start with, but if I knew two side lengths, let's say 4 and 7, but I didn't know the third side length of a triangle, but I wanted to know the maximum possible length and the minimum possible length that this could be, I would use the triangle inequality. So before we get into actually how to use the triangle inequality, let's look at, if I had three lengths, let's say x is the shortest length and it's less than or equal to y, which is less than or equal to z. So in ascending order, those are the three side lengths. And I had z here, and let's say x here, and let's say y here. What would happen if I brought these two side lengths, x and y, and I let them collapse onto z, and they didn't reach each other? Well, that wouldn't form a triangle. So what we need to make sure happens is we need to make sure that y and x are long enough such that they meet at some point, creating then a triangle. And there are minimum and maximum values for which this red triangle can then be formed. You might already know this, but what we need is for x plus y to be greater than z. So any two sides added together has to be greater than the third side. So I'm going to go through a couple of examples on how to use the triangle inequality to find those maximum and minimum possible values. All right, let's go ahead and get into it. All right, so let's do a couple of examples. Find the range of possible values for x, which is the third side of the triangle, given the following sides. So what I know is that 4 and 7 are side lengths to a triangle. I want to find also x. And x could be the longest side, or it could be the shortest side, or it could be the side that's in between, or it could be equal to one of the other two sides. I'm just looking for those values x in numbers 1 and 2 such that that's true. Okay, so the first thing that I'm going to do is I am going to assume that x is the shortest side. So using the triangle inequality, which we know is shortest plus medium has to be greater than the longest, or it doesn't have to be shortest plus medium, but it's got to be two sides added together. Their sum is greater than the third side. Okay, so I'm going to assume that's the shortest side. So that means x plus 4 has to be greater than 7. That means x has to be greater than 3. Okay, so now I've got a lower bound for x. So x has to be greater than 3. Well, let's find out what it needs to be less than. And the way that I can figure that out is now assume that x is the largest side. So 4 plus 7 has to be less than x, the longest side. That means x has to be less than 11. Ooh, that's an 11 twice. Okay, so there is my range of possible values for x, the third side of that triangle. Now, could it have been 6 and been between the two? Sure, absolutely. We don't need to test that, though, because that's not one of the endpoints for the interval. Now, let's look real quickly at potentially how we would find 3 and how we would find 11 from these two numbers, 4 and 7. Well, as you might have already assumed, 7 minus 4 gives us 3, and 7 plus 4 gives us 11. Therefore, in the next example, I can do this much quicker than setting up inequalities. What I would do is to find my inequality, I would take 28 minus 19 to find the lower end, which would be 9, and I would take 28 plus 19. There's your hack, guys. If that's what you're looking for, you just got it. So that'd be 47. And there you have your interval using the triangle inequality. All right, guys, I hope that this now makes sense and you can use it practically in the application within your geometry classroom. So hope it makes sense. Shoot me a message if you got a question that looks a lot different, or you just need help with, and I'd be more than willing to help. So have a great day. We'll see you in the next video.